Hello everyone. So today we are going back to section 8.6 to talk about change of base for logarithms. So one thing to note is that when you want to compute a logarithm with a calculator, most calculators will only do base 10 or base b. So in order to compute a logarithm with a different base, we're going to have to use a change of base formula. And what is the change of base formula? So if we let a and b be positive real numbers such that a cannot equal 1 and b cannot equal 1, then for any real positive number x, log base b of x is equal to log base a of x over log base a of b. So I'm going to show you why we get this formula, but before we do that, I want to talk about why can b not equal 1. So let's say, if I have log base a of b, so if b is equal to 1, what do we know? Then this is log base a of 1, but what do we know about this? So if I let this equal to y, actually we don't even need to do that, I've already showed you. So let's go back to the day for that, I think that was Friday's daily packet. So if we look at this first property here, log base b, so any base, as long as b is not equal to 1, and in our case a is not equal to 1, of 1, it equals 0. So going back to this, if b was 0, then I would have log base a of x over 0. And what do we know about fractions that get divided by 0? That is a big N-O. Right? So that's why b cannot be 0. So, but how do we get this change of base formula? So let me show you. So how about, let's let m equal log base b of x. So using this, what do I know? I know that this is equivalent to b to the m is equal to x. Okay? So if I start with b to the m is equal to x, okay, and I take the log base a to both sides, and I'm allowed to do that because I'm still, as long as it's balanced, it's fine, right? So now what am I going to do? I'm going to use the power property. So let's go back to this one. What's it state? So if I have like the argument to a power, what can I do with the power? I can make it a coefficient. So this is log base a of b equals log base a of x. Okay, so this was property 7. Okay, so let's get m by itself. So then m is equal to log base a of x over log base a of b. Right? But what is m? M we define to be log base b of x. So this is this. Right? And that is how you get the change of base formula. So I know we have this a here. So in our case, so this works for any. So if you wanted to change this, if you wanted to change a base 3 into a base 6, okay, that's fine. But normally, in our case, since we use the change of base formula so we can use it on a calculator, we let a equal to 10. Okay? So now, let's do some examples. So example 1, so we want to use the change of base formula for log base a of 5. Right? So one thing for me is I just remembered you want to divide, so the bigger number gets divided first. So we can just automatically say log base 5 over log log of 5 divided by log of 8, and then our a is 10, right? So yeah, that's just how I remember it, is that the numerator, it's the bigger number, and then the base is what we're dividing it by. So if not, if you want to label these, then we know b is equal to 8, and we know x is equal to 5. Right? And then since we want to do change of base, what is our goal? Our a is 10. All right. So we're not allowed to use calculators in this class. All right. So if I were to ask you if I were to ask you a question on a test about using the change of base formula, this is all I want. All right. So I don't want to see decimals, these long numbers. No. I'm not entirely sure about Alex. Alex might want you to divide it. If so, just get a calculator, get log of 5 divided by log of 8, and you'll get your solution. So I guess I can pull up a calculator here. So if I had log of 5 divided by how do okay, 1 second. I've never done logarithms on this calculator before, so give me a moment. If I do that, yeah, okay. So assuming this is correct, okay, could have gotten my actual calculator, but that's fine. Then Alex would want this, and then it depends on how many decimals. If it says to the hold on, 30. I'm going to say 9. Okay, because I don't think Alex would ask for more than 5 decimals. Remember, this is, so review, this is the tenths, this is the hundredths, thousandths, 10,000ths, 100,000ths. So, just a review on rounding, if this were needed. If Alex said round to the nearest tenth, what you do is, so this is the tenth, what you have to do is you have to look at the number next to it and determine if you're going to round up or down. So 0, so how do you know? So you round up if it is greater than or equal to 5. You round down if that number is less than 5. Right? So this, in the tenths, would still be 0.9. If they ask for the nearest 10,000th, so the nearest 4 decimal places, right here, we would look at this number, and this is 9, so 9 is clearly greater than 5, so then this would be 0.9031. Right? So that's just a little review on how to round. Right? But for our purposes, for when we do a test, I want it to look like this. Right? So now, this one was pretty straightforward. So now let's do this second example, which is log base of 1/6 of 10, right? So 1/6, I know that looks a little strange because fraction bases aren't the most common, right? But the only restriction we have for our bases is that it cannot equal 1. 1/6 does not equal 1, so we are good, and it's positive. Okay, so what am I going to do? We're going to use the change of base formula. So I'm going to take the bigger number, so log of 10 divided by log of 1/6. Right? So usually, so if you wanted, you can use a calculator, okay, on a normal whatever. So like if you ever wanted to know what the logarithm is, but for our class, we need to simplify this, right? So over up here, I couldn't simplify this anymore. That's why this was our final answer. But over here, I'm looking, some bells are ringing. So let's simplify this. So what do I know about log of 10? So actually, let's just rewrite this. So what is log of 10? Log of 10, so since there's no base, this is 10 of 10. And then, so that was the numerator. And then the denominator, so this is like, for example, log of x over y. Okay, this can be log of x minus log of y. Okay, remember my log has base 10, so that's why I'm not writing it. Right, so that's what this 1/6 looks like. Because it's division, it's telling me I can separate this with subtraction using the quotient property. So I can rewrite log of 1/6 as log of 1 minus log of 6. Right? So this was by property 6. Okay, so this log base 10 of 10, okay, what is this? So if the base and the argument are the same, that means that this by property 2 is equal to 1. Okay, and then looking at log of 1, so looking at property 1, so whatever base it is, okay, 10, 5, 6, 100, doesn't matter. If any log of 1 is equal to 0. So this is 0, and then log of 6, nothing. Okay, so that was property 1 and 2. Okay, so now we can simplify one step further. So this is going to be 1, and then this is negative log of 6. Okay, this is fine, but I usually don't like having negatives in the denominator, so I'm going to take it a step further. You can put it, I usually don't mind if it's on the top or to the side. Okay, so I'll just do it this way. Okay, and this is our final answer. And then again, if we have to do this on a calculator, so do 1, let me just clear everything. This is 1 divided by log of 6, okay, but there's a negative here. You don't have to, if you want to, you can, okay, but usually I just write the opposite if it's negative. So this is approximately, I lost my calculator. And let's round to the nearest thousandth. So this is 0.77. To write this one, I have to look at the digit next to it, which is 1. So 1 is less than 5, so this stays as 8. Okay, so that would be the answer you might have to give to Alice. Oops, this is negative. Okay, let's take it a step further. If we want to do 4 decimal places, 4, okay, negative, and then 0. You don't have to put the 0 here. Usually I don't because I'm a little lazy, but I know some people like to see that 0. So let me just change that. Okay, so if I want to do 4 decimal places, I'm going to write the first 3. Before I write the fourth one, I'm going to look at the number to the right of it, which is a 5. Since it's a 5, right, what does that mean? We're going to round up. So this is going to be 2. Right? So this is how you do the change of base. All right. So as you can see, this is our only lesson for today, but if you look at the calendar, you'll notice that there's also extra practice. So on your homework and for your examples of the day, I also added more from the last 6 topics that we've talked about. Right? So if you have any questions about logarithms, anything at all, please contact me because I know they can be a little tough, but I promise you with a lot of practice, you'll get the hang of it. All right, so this is it for today, and I'll talk to you guys tomorrow. Bye.